Alrighty, and here's the last section of Chapter 1. We're just about finished. We've got a few more vocabulary words, and then we'll look at some graphs to kind of talk about the way in which you can describe graphs so that everyone knows what you're talking about. So, first a few quick vocab words. The intercepts. You've already learned the vocab word x-intercept and y-intercept, so just collectively, the intercepts are the places where your graph crosses the axis, x or y. So, two types, x-intercepts and y-intercepts. Okay. Next is positive and negative. These just mean below or above the x-axis. So if you've got a graph and it goes like this, then let me highlight here, color. This part right here is positive because it's above the x-axis, and this part right here is positive, while this part right here is negative, and this part right here is negative. So your dividing line, when we say something is positive or negative, we're identifying the location or domain or x values where the output or y values are above the x-axis or positive. So we would say from here to here, so on this range the function is positive, its output values are positive, and from here onward it's positive. So when you're saying where, you say where it's positive, which is giving the x values or domain, and where its output is positive is the output is above the x-axis. Likewise, it's negative over here and between these 2 points. Okay, next page for some more vocabs. Increasing or decreasing. So increasing or decreasing just means if the function is sloping upward, y values are getting larger, that means it's going up that way. Decreasing means it's going down that way. So it doesn't actually matter whether it's positive or negative, it just matters whether it's going up or going down. So you can be negative but increasing on the rise. Likewise, you can be positive and on the rise, or you can be, negative and going down, or positive and going down. So this is really looking at the slope or the direction that the line is traveling, always when looking left to right. So when you look left to right, does it go up, increasing, or does it go down, decreasing? Okay, this word extrema just means the highest or lowest point. So if you have some graph that looks like this is an extremum because it is higher than all the points around it, and this is an extremum because it is lower than all the points around it. Okay. Relative maximum, a point that is highest among nearby points. So this is a relative maximum, and a relative minimum is the lowest point among its nearest neighbors. So this is a relative minimum. So relative maxes and relative minimums are the two types of extrema. And lastly, end behavior. So this is asking, what is the graph tending to do? What pattern is it following at the two ends? So typically, when we make a graph, we cannot graph the entire function because the function goes forever. So we graph the middle of it, the part that's doing something interesting, and then we just put an arrow at the two ends to show that the end behavior is tending to do, go in some direction. So in this case, the end behavior would be going up forever, up towards infinity, and over here the end behavior would be going down forever, down towards negative infinity. So some graphs, they may flatten out at the end. Some graphs may stop at the end. So we're just kind of saying, do they increase forever, decrease forever, flatten out to a constant value, or maybe stop? And so different graphs will have different end behavior, but that's what it means, the two ends, left side and right side. Let's do a couple of examples quickly, and we'll be all done with Chapter 1. Alright, so I just snagged this graph off the internet. It represents tadpoles in a pond over some amount of time. So in 1990, it looks like there was 200 tadpoles. Then the amount of tadpoles is going up, right? So during this phase right here, we would say the graph is increasing because the amount of tadpoles is rising, going up. So this is increasing. Then from here to here, the amount of tadpoles is decreasing or going down. So these are just exactly common sense, what you would think, increasing, decreasing. Again, we've got some increasing, and then we've got some decreasing. Okay? How about positive and negative? Well, the amount of tadpoles can't exactly be negative, so in this case, positive is upward. The graph is positive for all values from 1990 all the way to 1999. So we could say always positive. And I just put a plus sign instead of writing the word positive. Okay, what about extremum, relative max and min? So this right here, I think you can see, is a relative maximum. It's the highest amount. And this would be a relative minimum. And then we have one more relative max. Can you see where it is? It's not as high as this one, but this point right here is also a relative max. So relative max just means it's larger than the amount before, and it's larger than the amount after. Okay, the last thing to check is the end behavior. In these two cases, actually, the graph, it stops. It doesn't continue on, and you can tell because there's no arrow at the end. So this end behavior is the coordinate point, or a value of roughly, it looks about like that would be 600. So this is going to be about 500, yeah? If you think about it, 400, 800, so halfway would be 600. And this is right around the middle of that. So the right end behavior is about 500. And the left end behavior is 400 and 0, so 200. Okay? And that's pretty much all that we would be describing. So we'd say the amount of frogs is rising from 1990 to 1992. It reaches a maximum in 1992 of around maybe 1,700 or 1,500. Then the amount of frogs decreases for a year from 1992 to 1993, and it hits a relative minimum of around maybe 300. And then it slowly increases from 1993 all the way to 1997, where it again reaches a relative maximum of roughly a little over 600. And then it slowly falls again to a final population of 500 frogs in 1999. So the ability to take a graph like this and describe it in a few sentences is the target of all these words: increasing, decreasing, positive, negative, relative max, relative min, starting values, ending values, that kind of stuff. Let's take a look at one more example and then we'll be all set. Okay, this one is a purely mathematical example. It doesn't have any kind of real-world application implied by the labels on the axes. So we'll strictly talk about from a mathematical viewpoint. So where is it positive? Well, that's anywhere that the output is above the axis. So from here all the way to here. So from -8 to 0, right? That's the input values. From -8 to 0, the graph is positive. And from 3 onward, the graph is positive. So this goes up forever. So from 3 onward. Okay, where's the graph negative? From -infinity up to -8, we're negative. And from 0 to 3, we are negative. So that's positive and negative. We can tell this graph goes forever because it has an arrow on the left and the right. So let's talk about end behavior next. The left end behavior is it's going down forever. So we typically say -infinity because it's going to keep going. There's no value at which it will stop. It will keep going forever. And here we would say it's going up towards positive infinity on the right. Okay. How about where is it increasing? Where is it increasing? That's also something we can see on the graph. I'll change color here to green. Anywhere it's going up. So from here all the way to here, it's increasing. And then again from here all the way to here, it's increasing. And then where is it decreasing? It's decreasing obviously wherever it's not increasing. So let me try orange. From here to here, it is decreasing. Okay, and the point where it changes from increasing to decreasing, this point right here, is our maximum, relative maximum. It's not quite as high as this point over here, but it's higher than the ones around it. And then likewise right here, at the lowest point, we have a relative minimum. So the function is increasing to a relative maximum, then it decreases to a relative minimum, then it increases forever up to positive infinity. It's positive from -8 to 0 and from 3 onward, and it's negative everywhere left of -8 and between 0 and 3. So I know this is a lot to take in, a lot of new vocabulary words, but I hope some of them are kind of intuitive, and we'll do more examples in class. I'll see you then.